Hello everyone. Good morning. So, yeah, we are live now, and just give me a second so that I can check that are we live or not. Okay, are we live now? It's not showing here. I don't know why. Yeah, so we are live now. Yes, 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 yes. We are live now, and yes, yes, yes. Oh, let's start the game. Okay. So today we are going to learn multi-output classification. So let's start this thing. Multi-output classification. So first thing, what is it? Okay. The last type of classification type we'll discuss here is called the multi-output multi-class classification. Okay. Multi-output multi-class classification. Okay. Let's see what the thing is. Okay. We have learned about you know multi-class multi-class classification. Okay, I think. Yeah, let's check that. Yeah, it's multi-level classification. Okay, so there will be multi-level, many levels, and that will be classified. It is a generalization of multi-level classification where each level can be multi-class, but it can have more than two possible values. Okay, okay. So this is just a generalization. It's like more than two. Fine. To illustrate this, let's build a system that removes the noises from the images. It will take as input as noisy digit image. It will out the clean digit image, represented as an array of pixel intensities, just like MNIST images. Okay, fine. Notice that the classifier output is multi-level, and each level can have multiple values. So thus an example of multi-output classification. Okay, so let's understand this thing again. Notice that the classifier output is multi-level. Okay, output a clean image represented by array of pixel intensities, just like a NIST dataset. Okay, each level can have multiple values, and this is thus an example of the multi-output classification system. Okay, so notice that the classifier output is multi-level and each level can have multiple values. Okay, okay. Okay, so it is actually saying about one level as a one pixel. Okay, so it is saying that there is a one pixel of the image, then that is assigning one level. But yeah, like pixels can be 0 to 255. So there will be a lot of labels in one image. So that is a typical example. What it is saying, I'm just going to illustrate. Let's do that. And each level can have multiple values. This is thus an example of multi-output classification system. Okay, so okay, let's have it. The line between the classification and regression is sometimes blurry, such as in this example. Arguably, predicting pixel intensity is more akin than the regression to regression than classification. Okay, 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 okay. So predicting pixel intensity. Moreover, multi-output systems are not limited to the classification task. You could even have a system that output the multi-levels per instance, including both class levels and value levels. Okay, okay, okay. So just I'm going to explain you after. what it is saying that it has taken. Okay, let's take one picture. So, picture is actually made by pixels. Okay, so they are made by pixels like this or grid lines. Okay, so like how it, I'm just going to show you this image in pixels. Okay, so you can say this is the image of eye, and this is made by the pixels. What is the pixels? Pixels is just a small unit of image. You can see this is Abraham Lincoln. Okay, I'm just going to make it bigger, and you can see here like there are a lot of pixel points, and some are dark, some are light. So more darker means it's going towards zero, and more lighter it's going towards lighter. So it's like 0 to 255, and it is this is a black and white image. So black, this is the black and this is white, and there are gradients. Okay, there are gradients like this, like this, right? Yeah. And now this will be not visible to you. Okay. So you can see this is black and this is white. This is white. And that's assigned the value 0 to 55. Yeah. So this is something like that. Now what it is doing, that it is taking the every pixel as a label, and then it is predicting that label. Okay. So are you getting that this is something a high level, high level operation or application? You can say application because it's a high level application. Why? Because you are predict now from a noisy image. Okay, just take it as noisy image. What we are going to take? We are going to take some good image, something like this. Okay, so what it is doing, that it is first it is removing the noise. So it is not actually removing the noise, it is just predicting what is the behind the curtain. It is just predicting the right image pixels. Okay, so this is the point, guys. And let's start by doing some coding. Let's start by creating a training and test set by taking the MNIST images and adding noise to their pixel intensities with NumPy array rand int function. So this is the function, and we are going to do. We are going to adding noise to their pixel intensities, and then the target image will be the original image. Okay, no worries. We are just going to open the notebook, and this is modified. So our powerhouse, our power liquid is here. Hmm. So I'm just going to change the runtime to the CPU, and I'm just running it. Okay. So we have learned it from till here. Now what we are going to see multi-output classification. So it's the generalization, Classification is the generalization of multi-level classification. Okay, where you don't need. Okay, there will be multi-level. There will be not only the two levels. There are multi-levels. Okay, there will be multiple levels that will be getting predicted. Okay, it's like the pixels of images. Okay, so what we are going to do, I'm just going to make it italics. Then yeah, we are going to add noise to the data. Okay, okay, we are going to add noise to the data, and then we will predict the original image. So this is the point, guys, and yeah, okay, fine. Let's do it. It's quite simple and okay, let's do it. I'm just going to copy the code and I'll be explaining it that what's going on in the code and we'll be seeing all these things one by one. Uh, okay. So let's take a peek at the first image of the test set. So we are snooping on the test data so that you'll be frowning right now. Okay. So what we don't need the actual labels that it is 7 or not. What we are doing right now that we are adding noise to the original image and then we are predicting the clear image. Okay. So this is the point and okay. So we are just going to not going to take a break to. Okay, it's taking a lot of time. Okay, it usually takes. Okay, and how to see it? Let's see. This is the function. Okay, this is the function for that. And let's have the okay. Explain mode is not defined. Let's do it again. Plot digit is not defined. Okay, so I'm just going to search. It is the function plot digit. Okay, so I'm just going to show the clean digit. Let's see. Okay, it is making a function, guys. I think. Okay, so what I'm going to do, I'm going to do plot digit, and let's have a look. Maybe okay, MPL. Okay, it's getting errors. Okay, so it is actually deprecated. What we are going to do right now. Plot digit, we may have defined the plot digit before, but I don't know exactly. Plot digit to plot digit matplot clip. Okay, maybe there is a issue in this thing that it is unable to give the plot. Okay, so this is defined actually. Okay, so let's do that. If it will work, that will be fine. Okay. So it is again taking the MPL. Why it is taking the MPL? Oh, okay. Okay. So I'm just going to do that. And let's have this. It's really going to show me. Wow, that's fine. Okay. Okay. So what we have done that we have actually written or we have taken the function of the plot digits. So it have actually all the things that are important. Like it is a function, you just use that, and then we are also importing the MPL from the matplotlib. We are showing the digit. So this is most probably two. Okay, let's have this. Maybe, but it will again maybe generate the two because we have this here. Okay, so if this will work like that, there will be a different digit, of course. Really? Okay, I don't know what's happening. It should predict. It should. Okay, okay. Maybe it is. It is actually, it have made a. It have taken from like zero index. So that will be actually taken from the zeroth index. So that is okay. That is fine. Okay, but I want to see um noisy image and clean image. I'm just thinking to plot. Let's see. It is going to give me. Yeah. So we have got the code now in matplotlib grid. Let's have it. Okay, no worries. So you can see here, this is the noisy image and this is the clean image. So this it has predicted. Okay. So you can now see and you can call it two. Of course, you can also see this thing and call it two. But yeah, it can remove the noise. How it is removing the noise? It is actually predicting the actual output. And these are the labels, guys. These are the labels. So that is the good thing. Look close enough to the target. This concludes our tour of the classification. So we are done complete now. And you are now how to select the good matrix for the classification task. Pick the appropriate precision recall trade-off. Then compare the classifier. Then more generally build good classification systems for the variety of tasks. In the next chapter, you will learn how all these machine learning models you are going to actually work. So we are just going to do something very amazing, guys. And yeah, we are going to do a lot of things. Um, Maybe we can also go through the exercises. So we'll be seeing it in the next video. Thank you so much. That's